Hey gang, and welcome! So in today's video, what we're going to do is talk about significant figures. Now, why might I care about significant figures? Let's say you're massing something and you measured out some sugar and you measured 2 grams. Now, 2 grams may sound like you've got everything down pat, you know exactly what's going on. However, with the 2 grams, there is a little bit of uncertainty there. Do you mean you have 2 grams, 2.0 grams, 2.0000 grams? How many decimals are there? And that matters because if you're, for example, measuring sugar and you measured 2 grams, like on the scale, what that really means is you actually are measuring 1.5 to 2.4 grams of sugar. There's actually a wide margin of error in your measurement because your balance is measuring to the nearest gram. However, if you're measuring something and you have a new scale that measures, let's say, to the thousandth place, and you measure 2.000 grams, what that now means is that your margin of error is a lot smaller, and that measurement of 2.000 grams is really now going to be somewhere between 1.9995 to 2.0004 grams. And so that's why we care about significant figures, because it helps us understand the accuracy and precision of our measurements. And I'm not saying all the time you have to get 3 decimals or 4 decimals or 6 decimals. That's not the case. It's a matter of what is your comfort level. You want to find that sweet spot in terms of what is the simplest or the lowest number of significant figures that will allow you to still get the values that you desire or the final composition that you like and minimize the margin of error. So that's why our significant figures are actually very important to us. And so then the question is, so what exactly is a significant figure? And so a significant figure is the number of digits from the first non-zero number on the left to the last non-zero number on the right. So for example, if I had 1010, my significant figures would start at the 1 in 1000 and then go all the way to the 1 in the tens position, giving me 3 significant figures. Now, if there are decimals, then the number of significant figures extends to the final number regardless of whether it is 0 or a non-zero number. And so what I have here are a few different examples for you to try and identify what the number of significant figures are in these numbers. And so if you want to, you can pause the video right now and try to figure it out on your own. And that's great. But if not, continue watching the video and we'll go through it. And so what I'm going to do now is I'm going to identify where the last significant figure is in each of these numbers. And I'm going to mark it up with red. And so as you see with 2000, I'm going to have 1 significant figure. In the 2010, I'll have 3 significant figures because I start at the 2 and I migrate over to the 1. In 2010.00, I end up having 6 significant figures because not only because I have a decimal point, I'm going to include all of the digits in my significant figure evaluation. And then the final one with 2.010 times 10 to the third, which is really 2010. In this case, because I again have a decimal present, I'm going to include all of my digits in my significant figures. And therefore, I'm going to have 4 significant figures for that final value. And I just included all that right next to these different numbers. Now, a quick little fun fact is that when you have an exact number, so that's a number with a complete certainty, it actually has an infinite number of significant figures. And so one example of that is if I have a bag of oranges, and I have 6 oranges in that bag, that would be an example of having an exact number because I know I have exactly 6 oranges, no more, no less. And in that case, that 6 for the oranges is an infinite number of significant figures. Okay. So now the next question is, well, what happens when I start combining values? I combine values with different amounts of significant figures. So in this case, we'll start with multiplication and division. When you multiply or divide, the final outcome will have the same number of significant figures as the number that has the lowest number of significant figures in the operation. So, for example, if I have 0.0032 times 10 with a decimal times 6,050, if I did that math immediately, I'll get a value of 193.6. Now, I need to obviously take into consideration the number of significant figures. And so we're going to look at each of those individual numbers in that multiplication process to identify which one has the lowest number of significant figures. So when we include the number of significant figures for each of those numbers, what we see is that the 10 with a decimal has 2 significant figures, which is the lowest number of significant figures. And in that case, that final value of 193.6 is going to get adjusted to only have 2 significant figures, which will lead us to then have 190. And similarly, if we did it again, do another example where we have, let's say, 112 multiplied by 3.6 times 10 to the 4th divided by 819.85. If you do the math out without taking into consideration significant figures, you get a pretty long number, 4,917.9728. And again, we have to adjust this based on significant figures. And let's look at all the components of this operation, and we see again we have 2 significant figures, so that 4,917.9728 is going to have to get adjusted, and it's going to end up becoming 4.9 times 10 to the 3rd. Okay, now we talked about multiplication and division. What happens if we are doing addition or subtraction? And with addition and subtraction, when you add or subtract, the final digit of your calculated value will be based on the location of the final significant figure of your added or subtracted values. So between the values added or subtracted, the significant figure farthest to the left of the decimal will be the final significant figure of the calculated value. And again, we've got a couple of examples to practice this. So for example, if I have 280 minus 3.78, if we didn't take into consideration significant figures, we would have 276.32. Now, again, we have to adjust based on significant figures. So we need to identify where the final significant figure value is. So in this case, we're going to have 280. So we have the 8. And then in 3.78, the last significant figure is actually the 8 rather than the 7. And so in this case, what we're going to see is that with the 280, that 8 is the lowest, that's the lowest significant figure value. So we'll have to justify that 276.32 at the tens location, which actually gives us 280. So even though we did a subtraction, we still end up getting the same value afterwards, which I know is a little uncomfortable, but based on the significant figure convention and also taking into consideration the margins of error, that may happen sometimes. So now another example we got is, let's say we have 4.677 plus 9.3598 plus 0.98, and that, without taking into consideration sig figs, is going to give me 15.0168. And again, we'll take into consideration our significant figures and the locations of each of them. And what you see is that it's going to be the hundredths column from 0.98 that's going to cause us to, or that's helping us identify where to adjust our significant figures. And so in this case, that final value of 15.0168 is going to be adjusted in the tenths location. Or sorry, hundredths location, giving me 15.02. And finally, one other example problem is if I have 5.1 plus 1.199 times 10 to the 6 That would give me 6.299 times 10 to the 6th. And in this case, we're going to take into consideration, again, where the significant figures are. So 5.1 is in the tenths, 1.199 is in the thousandths, and therefore 6.299 has to get adjusted in the tenths column. And that's going to lead me to get a final value of 6.3 times 10 to the 6th. Okay. And so that's the rules and conventions for significant figures when we're doing addition, subtraction, multiplication, or division. And we see that when you're measuring things, there's a very big importance with our significant figures. And the decimals mean something. So it's all important things to take into consideration. And that's everything for this video. Thanks a lot for tuning in, and I'll see you in the next one.